What's up, everyone? Lance Hedrick here, and today we're talking about how data can inform your dialing in. Now, the last few videos I've done on my main channel have discussed some data and how it can help us and how we're dialing in. But there have been a lot of questions on the pragmatics of it. What's the practicality? How do we actually implement these different things? How do we implement the data you've shown us? How does this make a change in real life to what I'm doing, as opposed to just sounding scientific? And just throwing numbers at us. So I figured I'd come on here, I'd field some questions from the people in my Patreon, and then of course it'll go live for other people to kind of watch and hear what other people's questions tend to be. So to give you kind of background, the last two videos I did on my main YouTube dealt with what I call kind of like the fixed gap theory. So this was data concerning keeping all these grinders I tested at a constant gap, so not changing the dial, running different beans through and seeing the variation between the shots. And then the one before that, I'm actually blanking on for a second. It was going slightly finer, or actually going coarser and coarser and coarser, or actually, I'm sorry, go back again. Starting at a coarse grind size and going finer and finer and finer, and noting the times in the extraction yield and kind of putting that out as a way to buck against this idea of a volcano effect. For those unfamiliar with the volcano effect, it is this model that was proposed by a paper that came out a few years ago that has made its way through the coffee world, and a lot of people have informed their approach to coffee based off this paper. And this model says, essentially, in theory, the finer you grind your espresso, going from coarse to finer, 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 the higher the extraction should go in perpetuity. So if the finest setting you can go should be the highest extraction possible, because you're opening up more surface area of the coffee, making it easier to extract. But due to all of the different extraction kinetics or whatever that's going on during it, the mechanics of it, you're actually getting a declination of that extraction. So the finer you go, you kind of peak out at one area and then you begin to go back down at a similar rate. So the model they actually shows something that looks like a volcano, where it's even on both sides with a singular peak. So I kind of show, or kind of, I guess, debunk that with a set of data, but of course people can always add to it. So I did these two videos. Lots of questions on how was this help me, more so on the volcano video than on the other. But I figured, yeah, we'll go ahead and address them in an unfiltered. Typically, I don't like to. I mean, I talk a lot. That's no. If you're on this channel, then you've probably seen other videos of mine. You know that I rant. I love to hear my voice, apparently. So, but shockingly, I'm actually making these videos a lot shorter than they otherwise could be if I were to spell everything out. So I tend to try to lay out the general themes and then rely on kind of some deduction. But of course, there are new people to the channel every day who maybe don't follow all of my videos, which would be a lot. If you've seen all my videos, you are a rare breed, and I appreciate you very much. But that's a tall order because I make so much, and they're all long. But I try to take a little bit, I try to take some assumption of knowledge on the part of the viewer, and sometimes that's not okay. And so we're going to spell things out here as opposed to relying on deductive reasoning. So let's go ahead and look and see if there is some questions. Hi there. The volcano video helped me greatly not to immediately discard 16-second shots. They're usually pretty good sometimes. Yes. So one of the things I wanted to get across, and this is a common theme throughout a lot of videos and why I didn't harp on it in my volcano effect video, is faster shot times can actually be pretty incredible. So what has happened? What is this volcano shot theory? Now, I wish I had a whiteboard because I think a visual of this would be nice. I have this random Time Warp plugged in. That looks ugly. I don't like that black cord there. Do I have a notepad? I could do it on a notepad. Maybe if my drawers weren't so full, I could open this up. Yeah, here we go. This is going to be nice. This is going to be, in my head, it's really nice. In reality, it's probably going to suck. I don't really have anything but a green marker. So essentially with the volcano effect, we have a y-axis and an x-axis. Down here is fine. And over here is coarse. And then down here, let's say we have 16% extraction. And up here we have like 30%. I don't know. Now, in theory, you should have the coarsest should be the lowest extraction. Then as we go finer, it should continue to go up just like that. And the theory is that, the finer it is, the more easily it should extract because you're essentially making the water do a lot less work. So more water or the that amount of water should be able to get more work done because it doesn't have to fight through and waste a lot of time getting to the goodies that are available deep inside the coffee grounds. But in reality, what the volcano effect suggests is this is what's happening. So it goes up in extraction, and then due to the mechanics of extraction and the difficulty of water getting through evenly, it begins to descend in extraction. Now, what my data actually showed is it did something more like this. Now, there was a slight, if you looked strictly at the averages, okay, if you look strictly at the final points on that, the averages looked like it dipped a little bit as we went at the finest setting. But in reality, when you take into account the error bars, they were actually the same. Statistically, after we hit our peak, all of the numbers past it were the same number statistically. But there was a very obvious climbing of it. So why does this help us? What's going on here? Well, the reason this is important is this can help you understand your dialing in. I've always preached, even from the very beginning, my first video on espresso extraction, I talk about how when you get really fine, you get into this quantum realm where it's you don't know which way is up, down, side, left, right, through, whatever. You're lost. And so whenever you start dialing in your coffee, you should always start coarser and go finer. It's much easier to find the sweet spot when you do that. And if you do this, honestly, then you're following this chart just fine and you should be fine. But the reality is most people don't have the patience to reset their grinder with a new bean, go finer, 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 finer. They'll start with their last bean was, and it chokes the shot. And then they'll go a little coarser and maybe it helped a little bit. And so then they go, okay, well, I hit 30 seconds on this next shot. We're good to go. They taste like this doesn't taste very good at all. Well, the fact of the matter is they could still be over here. Now, you might go, okay, Lance, yeah, I'm over here, but it's the same extraction as if I were at the peak. The issue is, if you look at my data, the error bars get bigger and bigger and bigger and bigger the finer we go. And the shot time gets bigger and bigger exponentially the finer we go. So from the coarsest grind setting to the next setting, there was almost no change in time. Then the next finest setting, there was like a second or two. Then the next one, like 3 seconds. And as you keep getting finer, it exponentially climbs, which makes sense. And so when you hit that peak, you're at that, depending on the coffee, maybe 20 to 30 seconds. Then with some coffees at 25 seconds, the next finest setting might go to 40 seconds. The reason this helps is you'll know if you're going finer and finer, and boom, you have a huge jump. You're in that area, the no man's land where it's like, oh my God, this does not taste good. It has this sourness and this bitterness because it's over extracting pockets and under extracting pockets due to a heterogeneous flow. Now, what do I mean by heterogeneous flow? Sorry, I have a little phlegm. That's gross. Phlegm is a funny word to spell out. If you don't know how to spell it, it's PHLEGM. It's really weird. English is weird sometimes. So when I talk about heterogeneous flow, we have our puck right here. Okay. Now, if we had big grounds in here and a very unimodal grinder, so let's say we're using, the EG1 with ULF burrs. And so we have our nice big particle peak that's everywhere. Okay. And then we have just a few fines that are scattered throughout that are going to fill some of the voids, but not all of them. Water can get through pretty easily. So it's kind of going through. Maybe right here, it has a little issue. And so some of the streams all go through the same spot. But for the most part, water is able to find its way through pretty well. Then it comes to the bottom and kind of cascades to the center due to advection. And there we go. We have our espresso extraction. But what happens when you go finer and finer, and you get to a point where you're too fine, you have your particle peak, which they're smaller this time, okay? You have your particle peak like this, but then you have fines, and sometimes the fines can be concentrated in certain areas. So you're getting more, the finer you go, the more fines are going to be produced. So let's say we have a ton of fines over here, and we tamped it down, it just doubles down on our bad puck. So let's say it looks kind of like this. The water is going to come in, and it's going to choose these paths, right? But at the bottom, it could come to the center, or it could do a side pull, like just off to the side, and pull like that due to advection. It's wanting to come to the center. So it may not even look like that bad of a pull. But what's happening is you have these massive areas where it's heavily under extracted. But because the grounds are so much smaller than our previous shot that was much coarser, those grounds are going to extract at like 30%. Okay. So we have grounds that are extracted at 30%. And then these areas, okay, the ones that are barely touched by water are extracting at like 12%. Then when you average those out, based off of the volume of the bed that they are making up, when you average that out, your overall is around 22%. And you're like, oh, I got a 22% extraction. Or, oh, I did a 1-to-3 ratio, so it should be adequately extracted. When in reality, sure, the extraction yield is showing something nice, but you are extracting a lot more in some parts and a lot less in others. So, one more picture. What we don't want is a puck that's like this. Okay, we don't want a puck where it's like this area is 16%, this area is 22%, this area is 30%, this area is 27%, and then this area is like, I don't know, 14%. Okay, this is what we don't want, and obviously it would never be striated like this, but I didn't want to sit and try to figure out ways to show what I'm talking about. But overall, this is going to give us like a pretty normal 22% extraction. But it's going to taste horrible because certain parts of the grounds are giving us these acids in concentrations that others are going beyond. And then when they meet together, they're not giving you a good balance. Instead, what we're wanting is as much as possible to have evenness across the full puck. So we have our puck. We want, if we have the same striation pattern, we want it to be 22 here, 22 here, 22 here, and 22 here, and 22 here. Okay, that's what we want. Obviously, even that doesn't mean it's perfectly even. You can achieve a little pocket of here, it could be 25, and a little pocket here, it could be 21, of course. But the idea is we're trying to get the full bed as evenly extracted as possible. That's going to achieve the most balance. It's also going to give you the most repeatable experience. And it's also going to give you the most intense representation of the volatile organic compounds that come out at that extraction percentage. Okay, now, I've talked about this in the past, but in some data from Zurich's University, which I've talked about, like I said, it seems that at around the 19% with a lot of coffees, at 19% extraction, you have peaked the volatile organic compounds that are really nice, like the fruity ones, the floral ones, things like that. So if we have a graph here and we're extracting our coffee and it's going higher and higher and higher and higher, and then it kind of levels off, because obviously the early part of the extraction is much more intense than the later part of the extraction. At around here, we peak at those volatile organic compounds that we're really wanting in our coffee. As it keeps going, as the extraction continues, so here's those volatiles. How should I draw this? The volatiles, how should I draw it? Yeah, so those volatiles come out really quickly. It's like bang, but then they drop off, okay? And then around this part, you have another volatile that's starting to come out really quickly and drops off really later. And these are more bitter compounds, or what are associated with more bitter compounds. Now, I actually had the chance of smelling all these volatile organic compounds, the main ones that contribute to coffee flavor. And when they are bitter and bad ones, they are gross, and they are in coffee in that form. I just got to smell them in their pure concentrated form. So let me tell you, when I say there's literally a compound in coffee that's like dank socks, I'm not kidding. One of the compounds that heavily articulates coffee's flavor and aroma smells like musty socks when it's on its own in a concentrated form. Okay, genuinely. There's also one that smells like candied rose. It's wonderful, but it's very dainty. And this is why you get rose sometimes, but they only come out in their full concentration at lower extractions. That doesn't mean they're gone as it continues to extract. It means the ones that come out later they overshadow the more nuanced and dainty rose that you can get at the lower extractions. Okay, so whenever we're doing not this one where it's nice and even across the whole board, but we do this part of it, we have nice rows that come out into our final cup. But right here, we get dank sock that comes out, and that junk is overwhelming our rows, okay? Now, there's also a compound in coffee that is literally used to flavor cotton candy. Literally, the same exact compound they use in concentrated form to add to cotton candy. And so when you smell it, it smells like cotton candy. I was able to do a blind smelling of all these ones, and a lot of them I got correct as what they're actually used in. One of them is actually found in heavy concentrations in maple syrup, and it smelled like maple syrup. The cotton candy one's like, this smells like cotton candy, et cetera, et cetera. Anyway, that is, hopefully those visuals weren't terrible, but it helps me to talk when I'm using them. So when doing the volcano effect, it's important to know that you may have a quote unquote good extraction, even if you're not measuring the numbers, but definitely if you're measuring the numbers. Just because you have a high extraction doesn't mean you're at your peak. So let's say that you're consistently getting 20%, and all of a sudden you get 22. Just because you have peaked that coffee doesn't mean it's at its best grind setting. Okay. Time is still, for the most part, not a helpful thing to use, but it can help us if we watch the trends when we're dialing in. Okay. So for instance, if you're taking note of your espresso as you're pulling your espresso and you go, okay, my first shot, I put my coffee in, First shot was 16 seconds. I was like, wow, that's way too fast. So my second shot, I went 6 clicks finer. All right. My second shot went up to 30 seconds. And I was like, I actually think I need to go a little bit finer. So you go 1 tick finer because you say it tasted a little sour. You're like, it tastes a little sour. I need to extract a little bit more. You go 1 tick finer, boom, you're at 42 seconds. What the flipping heck? What the flipping crud? You're thinking, I need to figure out a way to get in between these two because this has to be the sweet spot. I shouldn't extract less than 30 seconds. No way, Jose. No way, Joseph. So you're like, what do I do? I need to get in between these two. And you get so upset and you're like, my light roast Ethiopia either gushes or chokes. Well, this is when you go, oh, you know what? Maybe the sourness is actually because the water flow through the puck is really poor due to being too fine. Maybe the 6-click difference here was too much. Let's go back and try this again. Then you go back to your 16 second. Instead of 6 clicks, you do 3. Now you're getting a 19-second shot. And you're like, oh, interesting. I went 3 clicks and it only moved 3 seconds. This means you're on this side of the volcano where it's coarse. But that's fine. A lot of times in this area where you're not ideal, tastes really, really good. And it may be not as repeatable. This is one of the things to understand. The coarser you grind your coffee, the less puck integrity it has. So you may have more variability introduced if you're not at the peak. The peak is where we have the most consistency without question. We have hella consistency at the peak. And in fact, there's a little bit more consistency in shot times and extraction yield, which don't say everything, just past the peak on this side than there is on the coarser side, which is interesting because the original paper says otherwise. But anyway, if we're dialing into that area, there's going to be a little bit more variance on that coarser side, but the taste, I can almost guarantee you, is better if you're using lighter roasted coffees. And it's because the puck integrity is so low. Puck integrity, I have a video coming out soon that will go really in depth with that. But if you understand the concept even a little, hopefully that is a bit helpful. So anyway, that is some of the practical things that you can take away from the volcano effect video. And to further just amplify what I said when I'm saying it's quantum physics, when you get down to super, super fine grinds, you can get lost really easily. So always start on the coarser end and walk it finer. And don't be scared of an ugly looking shot, okay? Especially if you're drinking lighter roasted coffees because the puck integrity is low. If you don't have an ugly looking shot, I can almost guarantee you're too fine and you have sourness in your shot. This is one of the issues in cafes is they don't know this and they're scared of pulling fast shots. And so they're pulling 30-second shots with light roast and they're sour. People are saying they're under extracting it when in reality, they're in the right range. If you go do refractometry, they're extracting at 21%. But it tastes bad because part of the puck is at 12%, part of it's at 30. Okay, so keep that in mind. The darker your roast of coffee, the less this matters, honestly, because it's more soluble and it's a bit easier to get really nice shots. But there's not as much going on in the cup. Obviously, you're burning out a lot of the organic material, which is fine. That's not an inherent negative. If that's your preference in your palate, good for you. I actually really enjoy darker roasted coffees as well. I don't always have to be uppity with my super nuanced complex coffees, though I am more times than not. Okay. Also, the stash is back for those who haven't noticed. Hit the like if you enjoy the stash. Okay. Now, that was a long rant. Sorry about that. Let's get back to all of this. Let's get back to all these questions. There's been a lot more since I last ranted. Let's see. I don't drink a lot of coffee, so my beans get to a point where they can't do long 9-bar shots, but the flavor is still great. What is happening? Great question. And also something that will be discussed at length in my upcoming video. But in short, if you have coffee and you don't drink it often, so it ages quite a bit, and you're not storing it like in a freezer or something like that to kind of keep it in a crystalline state, what's happening is it's off-gassing, and CO2 is actually a major contributor to back pressure and or also puck resistance or puck integrity. So if you have, let's just do a little thought experiment. You have a new coffee. 1 week off roast, you pull a shot of espresso, okay? You have it dialed in perfectly. It's 18 grams in, 36 grams out in 30 seconds. I'm not saying that's perfect, but that's just an easy to remember one. People use it all the time. And you're like, wow, perfect. 18 and 36 out, 30 seconds. That's great. You don't drink coffee for a few days. You come back. All you've done with your bag of coffee is you kind of, you take your bag of coffee, you roll it up. You're like, all right, cool. I've rolled it up and I put it upside down. It's not really adding any air. Fact of the matter is, air is still able to, CO2 is able to escape from this. It's not being held tightly. You can still have air come in and out, right? So what's happening is it's oxidizing, but not just oxidizing, it's releasing CO2. As you release CO2, the CO2 is one of the major contributors to back pressure or to resistance in your espresso machine. So the more CO2 you're allowing to be released from the coffee beans, the less back pressure you're going to be able to have, the faster the shot will be, the less capable it is of maintaining higher pressure. So you come back a few days later, it's been stored like this, you pull a shot, same grind size, same recipe, but it's 18 in, 36 out in 27 seconds. What the flipping heck? What the flipping heck? Why is this happening? I don't understand. You're like, okay, maybe that was just a whatever. It still tasted fine. It's fine. Then you wait a few more days. Coffee's still sitting there. You come back, pull it 24 seconds. What is happening? My grinder sucks. That's what it is. I need a new grinder. It's not consistent. You come back a week later, 19 seconds. Where's my phone? I'm ordering on Amazon right now. Golly, this is annoying. A week later, 12-second shot. I'm done with coffee. I hate coffee. Coffee's the worst. All that's going on is over those couple of weeks, this is degassing so much that it's not allowing for that creation of crema and that viscosity in the shot, in the extraction itself. And so it's not able to slow down the water from going through. So fineness of your particles, they affect the pressure and the speed that the water is able to go through, the flow rate of the water through the puck. So obviously, coarser grounds allow it to go faster and it will have a lower pressure. Finer grinds is going to stop it more intensely. Your grinder plays a part in this. What the particle distribution is like is going to have a dictate on what the back pressure is going to be. A lot of fines being produced, choke that bad boy out. Not that many fines, it's going to run through pretty quickly. Another thing that dictates it is how dark or light your roast is. Really dark coffee, it's going to act like cement, baby. You got to grind coarse. Really light coffee, you got to grind powder, baby, because guess what? That stuff ain't very soluble. It ain't going to want to go through, okay? Well, it does want to go through too quickly, actually, because it doesn't want to. The water doesn't want to sit inside the coffee grounds. It's too difficult. Water is so lazy. It always goes path of least resistance. So if it's going through and those grounds are not very brittle, they're not like exposed and like looking like the upside down from Stranger Things. It's going to be like, nah, fam, I don't want to enter you. I just want to get in that cup right now. And so you get a lot more watery looking kind of thing, and you don't get much pressure buildup. So until you choke the machine, it's because your peak particle is now essentially a fines. That's what happens. You go finer and finer trying to hit 9 bar with a really light coffee, and then all of a sudden you have a choked shot. Well, it's because you've turned your peak particle size into that of a fine, right? So now you're just grinding into Turkish powder, essentially. Okay. So the older your coffee gets, the less carbon dioxide it has inherent inside the coffee bean itself, the less likely it is to maintain pressure. Same can be said with the lighter the roasted coffee. The lighter you roast coffee, the less heat application there is, the less carbon dioxide is produced in the bean itself. Not only that, but the little bit of carbon dioxide that's produced in the bean, it takes a lot longer to escape. So you have this kind of thing where dark roast coffee, bigger pores due to longer heat application, higher heat application. So it's easier for the gas to escape, even though there is a lot more in it. Lighter roasted coffee, less carbon dioxide inside, smaller pores, so it takes longer to get out. So you could have a dark, if you're someone that enjoys a dark roast sometimes, a light roast sometimes, you may notice that after 2 weeks, your dark roast at your normal grind setting is flying through at 10 seconds. But you may notice your light roast doesn't really change for a couple of weeks because it's not off-gassing very quickly. And so that's also a thing that can happen. So hopefully that answers somewhere in there. I just pulled a 1 to 2.5 ratio in 17 seconds at 6 bar, and it was amazing. Shocked. Was roasted on the darker side, so results may vary. Yes, with darker coffees, the results do vary a lot on fast shots. And that's because what a lot of people are looking for with darker coffees is not the acidity. They don't want that. They want chocolatey kind of things. When you do really quick shots, it's harder to get that chocolatey experience unless you have a very high fines producing machine. But even then, if you have that, you're likely not running 16-second shots to get a full 1 to 2.5 ratio. But the fact that you're pulling a 1 to 2.5 tells me you're not going for chocolate bombs. You're going for a more balanced. There's acidity, there's chocolate, there's caramel. You have it all together in a nice harmony, and that's what it sounds like you're going for just off the bat. The fact that you're not doing 1 to 2 or less. You mentioned a 25 to 18-second window for optimal taste. I'm more on the 18 to 15 with 49 mil flare SSP or light roasters. Any tips in elongate? So 15 to 18 is great. And that's what I was saying with that was with that coffee, the ideal was 18 to 25 based off of the data and for the most part, the taste, though there were some decent ones below that at such a high flow rate coming out. This is the thing. When we're talking about time, and this is why we're not full circle or time matters a lot. It's not necessarily that. In that video, I used a specific coffee and showed the times for that coffee. Not all coffees will do the same at those times. Some coffees will have their peak at 20 seconds. Some will have their peak at 32 seconds. It just depends on the coffee, its density, its puck resistance, etc. The grinder you're using, the machine you're using, all these things will greatly shift those times, okay? So this is why I say don't rely on recipes you see online. 30 seconds is not ideal because some machines have a built-in pre-infusion. 30 seconds doesn't make sense, right? But also your grinder. If you have a really unimodal grinder, a 30-second shot is going to be terrible because in order to get a normal ratio in 30 seconds, you're grinding so fine it'll be bitter AF. You're going to hate it, okay? So what I was saying with that ideal range is based off of the data and consistency and taste, 18 to 25 was the best for that coffee. But there are some that faster will be better. The thing is I was using, which machine was I using for that? The Decent, and I was using the Linea profile, which peaks at 6 grams a second. Now, near the end of a shot, if I'm grinding coarsely enough for a 14, 15-second shot, that means I'm almost hitting 6 grams a second of output flow. That means the input and output are essentially matching, which means I'm having input flow of about 6 grams a second, which that is way too fast for water to travel through the espresso puck without having some sort of chaotic channeling or heterogeneous flow. That's way too fast. And as the puck is disintegrating, which it is, it's dissolving, right? You're dissolving and forcing through the basket in insoluble materials, but you're dissolving a hefty portion of that puck. So as that puck is depleting, and it is literally 1/5 of that puck is being in your cup at the end. How do you think we get espresso, right? 1/5, 20% or so of that puck of coffee that you have tamped and put in the machine, 1/5 of it is going into your cup. So as you're extracting the shot and that flow rate is increasing to maintain pressure, you are getting more and more brittle puck. And the faster the water flows, the more apt it is to find paths of least resistance because it's going to extract more and more unevenly as the shot goes on because certain areas had an earlier extraction start than other areas based off of the distribution of the coffees, the output of your grinder, a slew of different reasons. So when it comes to that the Decent I was using and the profile I was using, yeah, under 18 seconds didn't taste very good because the water variability was so high that it wasn't that great. And so if you had a lower water debit, yeah, maybe 15 to 18 seconds would be better. A 49 millimeter basket will allow for faster shots because it has a deeper puck depth, so it will allow for lower variability and less amounts of that wild channeling because it has a higher puck resistance. 12% sounds like your body fat these days. No, I'm still over 20, well over 20. Those photos I posted were very flattering, I'll be honest. The lighting was nice. Also, I just got back from 6 days in Madrid. I definitely put on a few libbies, just being honest, because I had cheesecake almost every day. I had to. I was in Madrid. Come on. Come on. We went to Botín, oldest restaurant in the world. I had freaking suckling pig. I mean, come on. I was a suckling pig. Let's see. What if pre-infusion goes into the mix? Just hit it for a few seconds, then extract 18 to 22 or less seconds. What if pre-infusion goes in the mix? Just hit for a few seconds, then extract for 18. So, like 5 seconds pre-infusion, then 18 to 22 seconds of extraction. So, like a 27-second overall, or 23 to 27 seconds. I mean, yeah, that's fine. So it depends on what you mean by pre-infusion, though, right? So pre-infusion, the more so we have a few different things that are pre-infusion, and it's very frustrating because it has so many different meanings. First off, pre-infusion is a misnomer. Literally, pre-infusion is infusing the grounds with water. It literally is. It's not before infusion. It is infusion. It's silly. It's a silly name. I hate the name. I'm just like, stop it. Okay. So what do we mean by the original pre-infusion on the original Achille spring lever? You pull the spring down, water fills the chamber, and is shot out with steam pressure. Okay? Steam pressure shoots it out at like 30 grams a second. That was pre-infusion. And then you would lift it, and it would shut off that flow, and it would just use the spring to compress it down. Okay? So pre-infusion at that point was going from 40 mils a second to a constant pressure. So it didn't really have pressure. It had steam pressure, so maybe 1.5 bar of pressure that was pushing it, which would soak the puck and maybe give you a few drips in your cup. And then you would let it bang, go up to 9 bar, and it would just push through nice and slowly. We fast forward, we have it on machines. Pre-infusion then turned into like low pressure pre-infusion, low flow pre-infusion, where you're just slowly filling the puck, which is terrible. Don't do that. It introduces so much variability. It's silly. When you fill the puck up slowly from top to bottom, and I've shown this in a video where I did a low flow pre-infusion. If you do that, you can do 10 seconds of it if it's at like 2 mils a second, which I think is what Slayer does. If you do like 10 seconds of that, that's 20 milliliters, right? 20 milliliters is not enough to fill up a puck, right? Right? If a puck is 20 grams or 18 grams, it's going to take at least 36 grams of water not escaping into the cup to fill up that puck, right? So at 2 mils a second for 10 seconds, half that puck is filled of water. That's it. And the visual I did is I knocked out a puck after 10 seconds of pre-infusion and showed you half was still dry. So you have 10 seconds of extraction at the top layer and 0 seconds at the bottom layer. And that's going to give you variability that is difficult to continue on. And you're going to have the top layer will be so much further in the extraction process than the bottom layer. It's impossible to get something more even. So pre-infusion, what is it at? Or are we now at like blooming, where we add water, we let it sit and let it fully saturate and soak, and then we hit it again, right? So it just depends on what we're talking about. But I always count all of the shot as the shot time. Okay. Now, this is more so for your own benefit. You don't need to be able to compare numbers to others because, like I said, unless you have everything identical, the numbers don't matter at all. You can't share your recipe with someone else because it doesn't matter. It literally will not have the same output unless everything's the same, in which case you can just say, I'm doing 18 seconds pre-infusion, 24 seconds full infusion, right? So the only reason to take numbers is for your own validity, for your own verification, okay? Or to share with someone that has the same exact setup as you, which is rare. Because they would need same amount of seasoning on the grinder, same exact machine, same water. Otherwise, sharing recipes is kind of a moot point, right? Do you feel like you notice those aromas and flavors more after smelling their pure forms? Um, Sadly, only with the nasty stuff. I now notice them a lot more because I now know what they smell like in their pure form. They get so the thing is those nasty ones, they are mixed with the good ones in a coffee because it is impossible not to get those compounds out. The compounds come out very easily. Some take a little longer to come out than others, and they vary in their concentrations, but they're kind of melded, so you never really sit there and think musty socks. But now that I have that in my head, I'm like freaking frick, what the flippin' heck? I smell musty socks. Dang it. So that, yeah, but all the other ones, honestly, I'd already smelled before in coffee, like maple syrup or rose or tangerine was one of the smells. So those things I'd already smelled in coffee. So it doesn't really make me notice them more. It makes me think, oh, I wonder if that is directly as a result of a high concentration of this compound. Whoops, sorry, excuse me on that. Could you, in theory, craft the perfect cup of coffee by mixing the concentrated VOCs? Well, the ones that I smelled were just the 10, I believe 10 or 12 most common ones. So the ones, not just most common, but the ones that are known to directly affect the sensory experience of the taster. Now, there are ones that are not proven to affect the sensory experience based off of maybe low concentrations or just they just don't have much of an effect. But in theory, absolutely, yeah, yeah, you should be able to. As far as the taste experience, right? Because your nose is the number one indicator of taste, followed by your tongue. But yeah, so you should. Well, not just from volatile organic compounds. You also have melanoidins and things like that. So I take it back. I take it back. I got too excited. Let's see. One small possible caveat: those of us who started liking coffee in cafes might be calibrated to some degree of unevenness and perceive it positively, right? I would say not necessarily. You just you The cafe experience you had doesn't necessarily have to mean sour acrid shots. There are shops in the world that aren't pulling sour shots. There is a window where you can make a really light coffee taste good on a flat 9-bar machine. Is it difficult? Yes, it is. Is it common? No, it's not. Is it repeatable? Not very. But you may be at a shop where they're pretty anal about their espresso, and they, if they're serving like straight espresso, they may even like try it before serving you a separate one to make sure that they're dialed in properly, or they may have specific parameters they do for just espresso as opposed to milk based beverages. I know when I was running a cafe, I helped open one back in the day. One of my rules was, when it came to milk beverages, depending on the size, there was different variances, different tolerances you could have for serving the espresso. With bigger lattes, if you're within plus or minus 5 seconds of the shot and it hits the grammage output, it's fine. No one will tell the difference. I can't tell the difference when you have milk in it. No one is. If it's like a 300 milliliter latte, which yes, they do in the US. If it's a cappuccino, it would be a smaller window. Cortado, even smaller. And then if it was straight espresso, it essentially had to hit parameters that were set that day. And we would set it 3 times a day, because throughout the day, the dial could change. It had to hit the parameters exactly. And that was that, right? So it was a more intense approach to straight espresso. So you may have a place that is very intense about their espresso preparation and service. But yeah, so it doesn't have to be uneven throughout all these different places. Um, and you may have been blessed with a shop that's doing over 20-gram doses. I don't know. And over 20 grams, you'll have a higher success rate than under 20 grams. And not just 20. It's not 20 is a magic number. But if you're in that higher range, you have a higher puck depth, you're likely getting a more, not likely, you are getting a more consistent shot than if you were to do 16 or 17 grams, which sadly a lot of cafes do. But it's to save money. It's to save coffee. I get it. But it's also why I push for smaller diameter portafilters. You waste less coffee. You get better coffee. And if shops are already doing 16-gram doses, just do 16 and a 49 and the taste will be 80% better. It's a random number, but it probably. So fresh beans taste bad because of puck resistance problem or bad VOCs not degassed, maybe both. Fresh is largely, I have found, bad due to the carbon dioxide inside of it. There is always, I call it roast taste, and which I shouldn't call it that, because I also call when something's roasted a bit too much for a certain coffee and I get roasty elements. I also say it's roasty. So it's not a great term to use, but there's a specific kind of carbonated water taste. You know how in carbonated water you have that like bitterness, but it's like it's I don't know how to describe it, but it's coming from the carbon dioxide, right? There's a taste I get when a coffee is a little too fresh, and I say, "Oh, it tastes like roast," meaning it's really fresh. Um, and this is what I think is the biggest thing that is impacting the taste, is too much carbon dioxide coming out. And a lot of times that can overwhelm the palate. Those other VOCs are coming out in the extraction; they're just overshadowed by some of the early trapped gases, namely CO2. At least that's what I believe. Regardless, it works in practice. So if you just rest the coffee until it's gone, you're good to go. What the mechanism is isn't as important, though. Of course, I would really love to know beyond a shadow of a doubt, but I'm very confident it is largely CO2 that is trapped in there that needs to be released. Yeah. Sorry for the silence. I'm reading through questions to see which ones are most apropos for the topic at hand. Um, Hey, Lance, in your opinion, why does the same coffee pull 20 grams in 15 seconds in the morning and 20 grams in 6 seconds at night? Same coffee, grind size, and prep. Thanks. Good question. There's a lot of other variables I would need, or things I would need to know about the setup in order to have some sort of postulation as to why that's happening. But genuinely, one thing could be humidity. If you're in an area where the humidity goes crazy, that can actually have a big effect on your shots. No joke. That's why it's very important when I'm doing experiments. I have an industrial size dehumidifier in my studio, and it is running and keeps it at 40 RH, 40%. Not higher, not lower. It stays right there while I'm doing my experiments because there will be crazy variability if I don't. I also have an air conditioner, keep it at 21 degrees. Done so. Or I guess heater in the winter months, but thankfully it doesn't ever get I wish it didn't get that hot and it got colder, but in reality, it gets really hot in here during the summer, and so I have to run the crap out of the AC when testing. But anyway, I digress. But yeah, so it could be a humidity thing. It could also be if you're pulling multiple shots in the morning to dial in and you get it dialed to 15 seconds. Some of that was due to heat up, and so maybe when it's cooled down in the afternoon, you're having to restart. Maybe it's going a lot faster. It could also be leftover grounds in the burrs that are affecting the shot. If you're going from that last dose to your next dose, so there are a lot of different things that it could be. It could also be the machine. Maybe the machine's not heated up as much, or it's hotter if you left it on all day and it's not normally on all day. There are lots of different things it could be. So it's really difficult to diagnose. Let's see. What time is it? Ooh, 9:59. Okay, we're actually good. I haven't gotten a text from the people coming here yet. Have I been to Italy yet? Of course I have, multiple times. I would say about 10 to 12 times, maybe. Pre-infusion is mainly for just lighter roast, right? No, it is not mainly for just lighter roast. You can do it on a really gassy coffee and it helps degas it. It also helps make a coffee more soluble. So if you're wanting to do faster shots or a more ristretto style shot and you want more extraction, you can do a pre-infusion with a darker roasted coffee so you don't get saltiness, which happens very often with 1-to-1 or 1-to-1.5 ratio shots. So pre-infusion or blooming is what I would really, say to do is a much better option than pulling a bigger shot for more extraction. So you can get a 1-to-2 ratio can extract the same as a 1-to-3 if you're very smart about your bloom or pre-infusion. Which again, I would prefer a term like bloom or early infusion or something like that. Let's see. I do pre-infusion on my La Pavoni at 1 bar from the boiler. So what you're doing is, yeah, steam pre-infusion is what people call it, or steam infusion, and that's great. I do that as well. That's what I count as my pre-infusion on the Pavoni, and on any closed boiler lever machine, whatever is the pressure coming out, that's what I let it do until I get a few drops in my cup, and then I go full blast, baby, full send. This one does relate in a way because I talked about resting, but I've talked more about rest time, specifically with different processes in Nordic style roasts on espresso. Resting is going to be highly variable based off of the style of roast in the coffee itself. So, in general, really dark roasted coffees, I say consume within the first 2 weeks. Not before about 5 days, 4 days. But I think about normally it's about 6, 7 days is like kind of ideal, and it peaks till about 13 days if you're not doing anything special with storing it. Then with like medium-ish coffees, maybe a week is fine, but up to about 2 weeks, and then maybe up to about 3 weeks before it really starts to kind of go downhill, assuming you've opened it. And then with light roast, I would say maybe 3 weeks, maybe 4 weeks. But with like, and when I say light, I mean like Nordic light, I guess, because Nordic light used to mean something different. I don't know. I don't think necessarily gotten darker. I think everything else has shifted a little lighter, which I know is a controversial take, but I think Nordic has kind of stayed where it's at, and everything else, like dark roast, have shifted a bit lighter, and medium roast have shifted a bit lighter. I should take this all back. What people refer to as dark roasts and medium roasts have shifted lighter, and now Nordic is kind of referred to as light roast because there's another light above Nordic that is referred to as ultralight. So unless you want to say there's like a light roast, which is really a medium, and then that you have like a Nordic roast, which is really like a light, and then you have like an ultralight, which is really like then it gets weird. Light, Nordic, then ultra. It gets kind of weird. But anyway, with like Nordic or light roast, yeah, 3 to 4 weeks or so. And then with ultralights, depending on the roaster, anywhere the roaster, literally the machine itself, anywhere from like 4 to 12 weeks. If it's a Loring, usually those take even longer, not longer than 12, but like 8 to 12 weeks. And depending on how light it is, it can take really long. But then it comes down to your storing, right? So the aging process really begins hardcore once the bag first opens. If they're sealed, if they're shut, and you tape over that valve, it is not really going to do very much. If there's nowhere for the CO2 to go, those valves are not very good. They do let some oxygen in. If it's done in a really good way, if it's a really nice one-way valve, the CO2 can push out the oxygen. And it's great. But oxidizing will happen right when you open that bag. So unless you're sealing it off in something in order to suck out the oxygen, or if you don't open it, when you open it is when that countdown starts. So I know that makes it difficult. If you buy a coffee that needs like 6 weeks of rest, don't open it at 3 weeks just to peer in. Have patience. Wait for it. Okay. I promise it'll be a lot better. But if you open it at 3 and then you're like, oh, it didn't taste very good, then you wait until 6 weeks and it's been open for those 3 weeks and then resealed, oxygen has been entered and it's not getting out. And so it's affecting the coffee. And then at 6 weeks, you're going to go, dang it, I should have drank it earlier. It was tasting better. So don't worry. Yeah. Some commercial grinders do have fans that blow on the burrs. Yes, this is true, but it doesn't do as much as you think because a lot of the heat generated is not due to the burrs being heated up. A lot of the heat generated is straight up at the fraction point of the beans themselves and how much they're rubbing against each other. So even if the beans were colder, if those beans don't have an efficient way of exiting, they're just rubbing against each other and causing loads of friction and tons of heat. What are your thoughts on lower dose baskets for 58 millimeters? 18-gram basket. We realistically dose around 20 grams. So want to limit caffeine intake. I'd like to get 15 grams. Oh, come on, Nick. Have you been watching my stuff? Low dosing's the worst. Of course, do it if you want less caffeine, by all means. I would suggest, though, looking into like there's a Kickstarter right now for a step down basket, 58 to 46. Then you can down dose all day and you'll have great shots, right? Because you're having adequate bed depth. The issue is in 58, when you go below 21 grams, that's when the quality starts, or at least I've noticed the quality anecdotally goes down, 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 down. When you hit 18, I've not enjoyed 18, 19-gram shots in years, actually. And it wasn't until recently I kind of found out why. But yes. What would you say is a reasonable time frame for steam pre-infusion? It just depends on the coffee. Honestly, you're not getting it's not too hot. Like, don't believe the crowds. It's not going to be too hot. Steam pre-infusion is fine. I usually do just a few drips, though, maybe like a gram or two in the cup, and then I go. I would say if you're doing something like five or more grams, it's probably too long. But yeah, it's probably fine. Okay. We'll do like one more question and then I'm going to end this. So if anyone has something super related to the last few videos, you know what? Sorry, I'm not taking more questions. No one talked about the grinder thing. And I thought that was really intriguing. So essentially what we had is the least amount of variability happened on the niche. Okay. Now that might sound like a huge positive, and it can be for a lot of people if you don't really care about other things. But essentially what you have going on, and we're getting the notepad out again. Duh. What you have with these grinders, where did I put the marker? It fell on the ground. What you have with these grinders is, depending on the particle size distribution, you're getting different variability from different shots. So what I did with these grinders, I took 4 grinders, Niche Zero, Breville Smart Grinder Pro, Compact PK100, EK43, or EK Omnia. I took them and I dialed them all into one coffee, to one recipe. They were all, let's say, 20 and 40 out in 30 seconds. I don't know what the recipe was. I can't remember. But I did them all to the same recipe. Then once they all had consistent 5 or 6 shots at that exact recipe, I started feeding different beans into each of them and recorded multiples, I think 3 or 4 of each grinder with every single bean. And I noted the difference, the shot time variability between them. Now, the EK, had some of the beans at the same grind setting as that 30-second shot had 10-second shots and all the way up to 100-second. The Compact, same thing. The Breville Smart Grinder Pro had like, I think the fastest shot was like 14 seconds and the longest was like 75. So a little smaller window, but still pretty big. The Niche was like the fastest shot was 16 seconds. The longest was like 38 or something. So I had a really small window, which is why so many people gravitate towards it. It's very easy to dial in to spec. Now, when I say to spec, that means to publish recipes, things that are accepted as what's good. The issue is, here is the highest potential taste you can get in a coffee. Now, that 100% taste is very difficult to achieve. It's very, very difficult. Okay. And you need a lot of things kind of perfectly in line. And perhaps you don't even want that with some coffees to get all of the flavor it has out because maybe some of it's that musty sock. Okay. Now, then down here, we have about 60% threshold. Now, I would say a really well aligned PK 100 could hit 100% of Tasty Town. Okay. The niche, however, can only really get to 60%. Okay. So the PK can get to up here, niche can really only get to 60%. Hitting 100% on something like the PK 100, though, is like 3% of the time. Okay. On the niche, hitting 60%, though, is like 80% of the time. All right. So you can get a much higher potential with something like a big flat burr with unimodal grounds, etc. You have a lot higher potential, but a lot more difficulty in reaching it. Now, you may get really good. You may boost that number up to 15, 20, 30% of the time. But without any skill, you can get the niche to like 80% without much effort at all, or 60% without much effort at all. Now, that's not to say the niche is a bad grinder. It's just to say that it has such a wide particle distribution. And what I mean by that is if we were to map the particle distribution by volume of fines, that means how much of that dose, how much of that dose's volume is fines versus all other particle sizes. So that means x-axis, we have particle size by diameter. Now, of course, we know that people think particles, grounds look like this, when in reality, some look like this, some look like this, some look like this, some look like this. They're really random. They don't look like this. But when we're doing particle size analysis, a laser assumes sphericity. So when it looks at this, it assumes a sphere. Okay. And so this is the diameter that it gives us. So also keep in mind that. But anyway, down here we have the microns of diameter. All right. So down here we have like teeny tiny fines. And up here we have the big boulders. So let's say right here is our grind size. All right. This is 200 microns. Oh my God, I can't. Yeah, that's right. You can't really read it. Sorry. You have like 200 microns. And then, of course, we have, less and less and less and less and less. You have more and more and more and more and more. The ideal is for the majority volume for unimodality would be right here. So, for instance, something like the PK100 that we hyperaligned and slow fed looks something like this. Right? So it had a hump of fines right here because all grinders are going to produce that bimodal peak. And then we had a really nice narrow peak where, there were particles at 190, particles at 210, whatever. But it was pretty nice like this. The niche doesn't have that many more fines, but it does this. Okay. So what it does instead is it has particles at 150, 160, 170, 180, 190, 200, 210, 220, 230, 240, 250. And it's a nice wide area there. There's not a ton of fines though. There are fines, don't get me wrong. There's more fines in it than the PK100, but it's much wider. And this allows for much easier dialing in. So if the ideal dial in is a peak particle of 190 and you actually have it dialed to where the peak is 200, well, guess what? That's so little off the center, you're likely going to get the same time shot anyway. Same with like 210. Maybe you're off by 10, 20 microns. You're in that wide parameter, bada bing, bada boom. You've got a shot that's decent. The issue is, because of that, it's a lot of blending going on, and you don't really get ideal shots. You also get a lot of over extracting the big portion down here that is too fine for that, and under extracting the big portion up here that's too coarse for it. So you get a lot of blending of a lot of different elements, which isn't necessarily a bad thing if that's what you like, but that was kind of the idea of showing it. Is there are some grinders, like I see people all the time complain they don't get good shots with their hyper aligned, whatever it is with SSP, whatever's. They're like, oh, I need a new grinder because I can never get a good shot with this. The bursts suck. No, it's just a really teeny tiny little baby window. Okay, the window is teeny tiny. All right, and the more narrow the particle distribution, the more teeny tiny little baby window gets. Okay. Anyway, I think. Oh, someone said, according to Cafe Master, guys, the Weber Key MK2 has a notoriously wide particle size distribution. This is accompanied by low extraction yields. Yes, that is also a fact. And it's something I've talked about with the HG2 for years. I just never actually took the measurements because I could see it visually. That's one of the few burr sets I could visually see had a crazy particle distribution, like very wide. Whether it was in the Ari's MX Cool, which has the 83 millimeter Mazzer cones, whether it's in the Mazzer Coney, whether it's in the HG2, whether it's in the Weber Key, whether it's in the Lin Prime 1, whatever the frick it's called, whether it's in the Swan grinder from La Marzocco, all of them, every single one, you can visually look at the espresso grounds and see how wide of a particle distribution it is. It's wild, the boulders you see in it. And so because of this wideness, you do have a lower extraction percentage overall because the amount of boulders that are filling it up. And even if I'm not talking about, some grinders will actually have another tiny little hump down here of boulders. But even without that, when you look at this peak that goes really high, the biggest boulder's like right there. This one, though, you have a huge fraction of boulders, which is going to degrade that overall extraction yield quite a bit. And so, yeah, they're right to note that. That's great. Well, it's not great because a lot of people have 83 millimeter Mazzers and they may like it. And that's the thing. You might love it. And that's completely valid. Again, nothing is wrong in tasting coffee. If you enjoy something, freaking enjoy it. You know what I'm saying? That's great. I don't really care. I use my HG2 mostly because I love the feel of it, but I'll do it with dark roasted coffee because the particle size distribution honestly matters a lot less with darker roasted coffees because it's so soluble, so brittle. I'm not saying it doesn't matter at all. So if you're someone that shelled out $2,000 on a grinder and you drink super dark coffee, you're valid in that if you like it. Right? I'm not trying to diss on it, but objectively, there are a lot less organic compounds in a darker roasted coffee to its lighter roasted counterpart. That's an objective fact. The more you roast a coffee, the longer a heat is applied to it, the more organic matter you're burning out, the more volatiles are released, et cetera, et cetera, et cetera. And amen. Okay. So it does matter less relative to a really light coffee. It just does. And for me, it doesn't matter as much. And so, yeah, when I'm using old style levers, I love to use my HG2. But anyway, I've not done a video on it, though, because I don't really like the taste. Yeah, there you go. Okay, I think we're good. We're good now. Okay, yeah, I think we're good. There were other questions, but I mean, I've gone over my allotted time. I wanted to keep it under an hour, keep it bite size. For Lance, that's bite size, as we all know. Dang, my mustache is looking nice. I was scared it was too short to go just stash, but you know what? I'm feeling a little Model S. You know what I'm saying? I'll take it. Anyway, thank you all for watching. To those in the Patreon who are watching this live, thank you very much. If you are watching this and you're not in the Patreon, you're not in the Discord, you're not able to come to these lives that I do every so often, we'll consider joining the Patreon. Make sure you hit the like and subscribe if you haven't already done to this unfiltered channel, because guess what? That really helps the channel in general. But thank you so much. I hope that you brew something tasty today. And cheers.